Hey everybody, welcome back to my YouTube series on Codesys, the open PLC open based platform for a lot of PLCs. And this particular video is going to be on timers and counters. And yeah, so we'll just get diving right into it and get going. Timers and counters. So in the Codesys world, if you're not familiar with PLCs, if you're just learning PLCs, all PLCs are going to have timers and counters built into them. Timers to time things or create time delays, and counters to actually count things. Okay, so now what we're going to see in the Codesys world, you'll notice down the right hand side we actually have two types of timers listed in the main instruction set and two types of counters. In reality, we're going to see there's actually a third timer and a third counter that's in the box style, and I'm going to show you that. So what are the timers that we have? Well, we have a timer on delay and we have a timer off delay. So we'll start with timers and take a look at them. So we have a timer on delay and a timer off delay. Timer on delay, as the name implies, it's going to delay the output from going on for a certain amount of time. A timer off delay is going to delay the output from going off for a certain amount of time. Okay, and let's take a look at how to build them, and then we'll discuss more application, actually thinking about an application. Okay, so let's try this. So I'm gonna right click here and create a network below, and I'm gonna put a timer on delay down. Now you'll notice, like some other instructions that we've seen, this timer actually needs an instance up on the top. It gives us an instance name. You know what? I'm gonna actually change this. Okay, I'm gonna change it to just timer 0, T0, right, and leave it at that. Say okay, it's timer on delay. Okay, and then from there I'm going to say PB2, and I'm going to use PB2 as my contact in front of it, so I have to declare that as well. And then of course I'm going to actually put a coil on the output of the timer, and that's the coil that the timer is actually going to drive at some point. And I'll give that a tag called light 2. Now, what happens in this structure, this timer that we've got, there's actually two parts to it, two extra parts that we have to deal with. It's a timer, so you're going to tell it how long to time for, and what that actually is it's referred to as the preset time, or the PT. Now, I have to put a tag here, put a symbol in here to give it an address. I could put a raw value, but I'd prefer to put a symbol in there, something that I can change over time if I want to. So I'm going to go and do that. And I'm going to actually use this same structure name, T0, and I'm going to say underscore PT, just to give us some relative to both the timer and what part it is. Now, you should notice something interesting. The data type over on the right here, it's of data type time, which is a little different. It's not just a number now. It's not just a bit. It's not just a number. It's actually a time value. And of course there is a specific format to it. Let me show you how you can, an easy way to find the format within the software here. Click in the initialization area, which we're going to have to do anyways. We're going to have to initialize this to some number anyways. So click in there and select the ellipsis button, which will take you into the initialization value. Okay, now I can actually leave it as a init value 0 milliseconds. I could actually change it to, say I wanted 5 seconds. I could say 5,000 milliseconds if I want. I can do that. Or what's interesting is there is actually another format. You can kind of get the point here and how it's working. Instead of milliseconds, I'm going to say 5 seconds. Just put an S in there and that'll give me 5 seconds. And say, sorry, it didn't complete it. I'm just going to go complete it up here, 5 seconds, and say okay, and it will put the value in there. You can see in the declaration up at the top in the header, it did actually make it as 5 seconds. See that? Okay, we're going to do a tag for the ET as well. So T0 underscore ET, which gives us our tag for our elapsed time. That's what that is. It's the elapsed time value. And I'm going to say OK, and it's also going to give me a tag based on the data type time. Okay, that's good. Let's try it out. Let's download to our simulator, put the simulator into run. Once it's compiled, it's downloaded it. It's going to put us online. I'm going to say start, and it's going to actually start the project for me. Now, I'm going to double click PB2, right click, say write, and you can see it's actually timing that value. After 5 seconds, you can see the light goes on. This is a timer on delay. It's delaying the output from going on for a certain amount of time. Okay, I'm going to reset this. You'll notice when I reset PB2, it resets the timer value too, the elapsed time. See that? So the timer itself will get, it will actually get reset when you reset the input. So I'm going to double click it again, just show you how it works. Right click, and you can see it actually goes up to 5 seconds. Okay, that's great. Now, what's interesting is there's a couple other things that are part of the overall structure of the timer. So let's actually go out, and I'm going to show you that. So for people that are coming from the Rockwell Automation world, the Allen Bradley world, they're used to different parts that they can use, like the Q bit and, or sorry, the done bit and the timer timing. That's in the Allen Bradley world. Here in Codesys, it's referred to as the Q output or the Q bit. So there is a, you can use the Q bit. There is no timer timing, but I'm going to show you how to manufacture that. So let's use the Q bit first of all. So instead of doing an output like I've done here with light 2, what I'm going to do is drop down a contact, and I'll drop down a coil. The coil I'm just going to tie to some new light 3. And then for over on the side here, I'm going to actually put the Q bit. Now, this is kind of interesting how this works. All you have to do is put T0, and then you actually get the structure. You can get access to the structure of T0. T0 has, you'll notice here, there is several parts to T0 as the structure that it created. When it created this instance of the timer, it created this structure for us. And part of that, one part of that, is the Q bit. So I'm going to double click, and it puts the Q bit in. You know what? For future reference, you can just type Q. You can just type .q and you're good to go, right? But you get the point of where it came from. Okay, the other thing is the timer timing. I'm going to right click and put another network in. There is no timer timing bit in the structure, but the timer timing bit is nothing more than basically the timer is running, but it hasn't been finished yet. So what we can do is we can manufacture that. I'm going to actually create this. So it is PB2. So if we take PB2, when the timer's actually been told to run, which is PB2, but it's not done, it's not done. And actually to get that not of the Q bit, what I can actually do, I copied across this instruction, and yet I need the not, or the inverse of that, the negation of it. So to get that, what you do is you right click it and you can select negate, and it'll change the instruction for you. See that? Then of course I'll just put a coil down there just to give us something to trigger. So light 4, and we're good to go. Okay. Let me download that, log in with download, say okay. All right, so I got to turn this into run. Let's see this work. So we've got two things. We've got the done bit, the Q bit as it's called here, and we've got what we've manufactured, what we used to call in, let's say, the Allen Bradley world, is the timer timing bit. All right, so it's going to turn on when the timer's timing. So let's actually watch this. So if I double click this and write it, you can see that sure enough, the timer timing is timing as it's running. And it will turn off. The timer timing turns off when it's done, but the done or the Q bit will turn on. Of course, if I double click the input and reset it, it'll reset that, both the timer timing and the Q bit. Yeah, that's how an on delay timer works. Okay, so let me actually go offline, log out, go offline, And let's actually add a timer off delay. Now what's interesting is I can very easily, if I want to, I can very easily go and select, I can drag and drop a timer off delay, put a new rung down here. I could put a new rung and just show you the timer off delay. But here's something interesting. So again, for people that are used to the Alan Bradley world, they're used to being able to just type in the instruction and change it. Well, you can do that here. You can actually go in and change this if you want, and change it to a timer off delay. See that? Now, there is one gotcha though. There is one thing that you have to be aware of, is that the structure of T0 when you created it though was of a data type timer on. They don't just use a base timer structure. So they actually have a specific timer on and a specific timer off delay. All right, so I'm going to change it. You have to change it to a timer off delay structure for this to actually work. Okay, so that being said, now that the instructions actually changed, let's actually watch how this works. So I'm going to say log in. Yes. And it's going to download it. I'm going to press play and actually go in and toggle PB2. Now what's interesting is you'll notice I've toggled PB2, and this gets a lot of people when they first see this. This is pretty strange looking for most people when they first get used to PLCs, but this is actually the same across all PLC brands. The timer off delay, what happens is you're delaying the output from going off. Therefore, the output actually has to be on at some point. So by turning on PB2, we turn on the output. Qubits turned on, you can see that. Okay, the qubits turned on, but it's not timing. See that? It's actually not timing. So let me release PB2. It's going to delay it from going off. So if I double click and release it from going off, it's actually going to start timing. You can see it's holding it, it's delaying it from going off for 5 seconds, and then it turns it off. Okay, let me try that one more time. So double click, it actually delays it from going off. So what's interesting is, let me give you a couple of just application ideas here. So in the case of the timer on delay, maybe you're using that to turn maybe you're using that in a motor starter. Let's say you have a motor starter and a start-stop station motor starter, and you want to actually delay something. You want to delay the motor from turning on for a certain amount of time. You're going to delay it from going on so that you can turn on a loop pump. Well, the timer timing bit could be used for the loop pump. You could run the loop pump for 5 seconds before the actual timer turns on the output or the motor. Now, in the case of a timer off delay, the example would be, what if you wanted to turn something on before the output turned off? So, for example, again, maybe you want to turn a fan on the motor. Before it turns off, you want to run a fan on the motor for a certain amount of time. Okay, so there's an idea, a couple ideas of the just applying the timer on delay and the timer off delay. Okay, so let's move on. I'm going to delete the timer off delay and come in and actually clear. I'm going to clear my tags up top here just to clear it out. And let's do this. Let's actually add the third timer, the timer that's not listed here, the one called the pulse timer. To get access to that is actually through the box area over on the right hand side. You can see the box area. What you do is you drag and drop a box down, and this is probably the first time you've seen this in Codesys. I know this is the first time I've used this in the videos, but these box areas, they give you access to a whole bunch of instructions. Now in our case, we're going to be using the timer and we're going to be accessing the pulse timer. So double click, and it's going to create a pulse timer for us. It has to create an instance, which it did up top here. It's creating an instance, and I'm going to go and give it a tag for the input, PB2. Again, it's going to need an output. So I'm going to drive it with light 2, like that. And then from there, I can actually go and, again, put in our PT and our ET. So I'm going to say TP0 underscore PT. And as I was mentioning, this is a data type time, and we want to initialize this. So I'm going to go in just to give you the extra practice and say OK, and change this to, let's say 5 seconds. I'll do the same thing. I'll do 5 seconds, same format as before. Of course, we need something on the ET as well, so I'm going to say TP underscore 0 underscore ET, and create that tag, and of course it creates it also with the data type time. Say OK, and we're good to go. Okay, let's test it. Log in, download, say OK. It compiles it, downloads it, and I'm going to put it into run, and let's try it out. Push button 2. Force that value. You can see it turns on. What this is, the pulse timer is going to do, it's going to pulse that output for that amount of time. So you see that the output went on and now it's back off again. As long this input, when this input goes on the rising edge of that input, it's going to trigger this output for that amount of time. So even if I'm going to, you know what, maybe I'm going to double click here. Let's change this to 10 seconds just to extend this, to give me time to change the input a little bit. I'm going to right click, write the value. I'm going to change this. I could have changed that at the same time. False, write the value. Now, so watch what happens now when I reset PB2. I'm going to try and reset it. What I'm going to do is trigger PB2 to actually turn on the timer, and then I'm going to quickly turn it off. And you'll notice that the output stays on for the pulse time that's set here. All right, so it's going to stay on for that 10 seconds. Double click, right, double click, right, and you can see it's still pulsing. See that? Up to our 10 seconds. This is a pulse timer. Okay, so from there, let me show you how counters work. That was timers. Let's actually go on to showing you counters. If I drop down a counter up instruction, sorry, I've got to make a rung first. Got to make a network. If I'm going to drop down a counter up instruction, you'll see how this works. Again, just like timers, it's going to create an instance of that counter for us, and it's going to be in the format of a counter. When I hit enter here, you'll notice that it's going to be a CTU type. Say OK, good to go. I'm going to give it a tag symbol for my count up input. So PB2. This is my count up input. That's the input that's going to actually tell it to turn on. I'm going to actually put a coil on the back here. This is going to be my output. When it's done, we'll actually see this turn on. Say OK. And I'm going to give it something for its reset. You have to give it something for the reset. PB3. Just like our timers, we also have a couple of tags or areas that we've got to set. The preset value, the PV, and the current value, or CV. So again, CTU, I'm going to use CTU just because this is what I used before. Preset value. You'll notice this time it's not of a data type counter or time base. It's a word type. It's a word. I'm going to give it a preset of 3. I just want a small preset because I got to toggle it, so I don't want it to go I don't want to spend a lot of time on the video toggling. I just want to do it a couple of times. So preset of 3, and you can see up in the declaration, you'll notice that sure enough, it set that equal to 3. Okay, CV, CTU underscore 0 underscore CV, enter. It's a word, say OK, and sure enough, there's my counter up. Log in, let's try it out. It compiles, and I'm going to press play, and it's good to go. Okay, so I double click on the push button 2. I'm going to do this a couple of times. You'll notice when I do this, it's counting up. See that? Two, and of course my preset is 3. So once I get to 3, the output turns on. See that? Come on. Okay, interestingly enough, let me hit it again. Let me actually hit this push button 2 again. See what happens. You'll notice it actually counts beyond. See how it actually counts beyond? So it can actually keep going. If your input keeps going, it'll just keep counting up. So if you're using this as an actual counter, you're counting how many parts are there, and you don't care about the preset value, you could just you can disregard the preset value, and as a matter of fact, even the output. If you just want to count how many parts are there, you could just use it that way. If you do want to use the Q bit, then you would set the preset, and it'll turn on once it's greater than or equal to that preset. Okay, if I want to reset this instruction, I'm going to reset it with my reset input, and you'll notice it clears the Q. The Q bit turns off, and the CV gets set to 0. That's a counter up. Good to go. Let me go off, log out. Let me actually do the counter down now. Let's see how that works. So insert network and counter down. And I'll put a new one on there. So countdown 0, and I'll say PB4. I'm going to put a Q on it. Light 3, enter. All right, and PB5, PB5. For the load, this is not a reset anymore. It's called the load. I'll explain that in a second. Let me go put my tags in here. CTD underscore 0, 0 underscore PV. All right, again, it sets it as a word. I'm going to set CTD underscore 0 underscore CV. Enter, and it's also a word. There's my tags for my counter down. It does my compilation. It compiles it for me and downloads it, and I'm going to press start, and sure enough, it starts going. So watch this. Now the counter down, I'm going to load it. Oh, you'll notice the PV is set at 0. I forgot to set it to something. Let's actually set it. So I'm going to double click it here, and let's set the value to, let's use 2, just so we don't have to go very far. And I'm going to right click and write that value. So when I trigger the load, it's going to actually load 2 into the current value. It's going to load 2. Watch this. So it loaded that value, and it's set at 2. It's a count down, so it's going to count down from some value, the value you load it with. So I loaded it with 2, and if I count down from there, look what happens. So PB4, I'm pressing it, it's down to 1. I'm going to hit it again here, and it's at 0. Once it reaches 0, it will turn on the Q. So what happens is you load this counter down with a value, and then it's going to count from that value down to 0. Once it reaches 0, it will turn on the output. Okay, so what's interesting in the counter world in Codesys is In other PLCs, you could just combine the count up and the count down together in the same structure, and basically they would count on the same counter, and you would be able to count up and down if you wanted to. What if you wanted to count up and down all in one process? Well, with this method, it's a little difficult because our CVs are actually different, right? In Codesys, we actually have a third counter, a count up, count down. So like we saw with timers, you have to get that, you get access to it through the box. So watch this. I'm going to right click, insert a network, and I'm going to drop a box down this time. And this time I'm going to go in and say, I want to use the standard counter, count up and down. There we go. It's going to create an instance of that counter up down for me, counter up down 0. And look at the type. The type is a specific type, counter up down. I'm going to say OK. I have to put tags on it, so I'm going to say PB6. OK. PB7. Say OK. PB8. OK. OK. And I'm going to put something on the queue. And I'm going to actually put something on my QD. So I'm going to say, see, I'm going to use that structure. Because again, just like we use with timers and counters, the other ones, I use some kind of structure on it, right? So based on the timer or counter it is, I've used that as my reference. Now, why I do that, I guess I haven't explained maybe why I try to keep them similar. Why I do that is because you might have multiple counters. You might have multiple timers, multiple of the same timers. So that's why I like to actually make it relative to that specific one. So in this case, CTUD underscore 0 underscore QD. Okay. That's a Boolean. This is interesting. This should sort of be this should maybe raise your eyebrows a little bit, because this is an actual Boolean. This is a bit coming off this, and I'm going to explain what happens there in a second. Because all our other tags that we played with have always been some kind of number, whether it's a word or a time value. Okay, so from there, I need to do a PV, so CTUD underscore 0 underscore PV. It's a word, say OK, and I'll do that for the CV as well. CTUD underscore 0 underscore CV. Enter. Word. There's our counter up, counter down. Now, I used PB6, PB7. I used my own tags, my own push buttons there, right? But in reality, I could have actually called this counter up, counter down, reset. I could have gone through and actually named these tags or symbols whatever I wanted to do, whatever I wanted to name them. But anyways, so from this point, that's fine. Let me actually download it and let's try it out. Oh, it didn't like something. It didn't like something that I'm doing. Oh, I didn't put my output here. Light 4. Let's do that. Say OK. And again, log in. Try downloading and see if it compiles this time. I think it's going to be fine. Good to go. All right, put it into run. Let's try it out. So counter up, count down. So what's interesting is we have a reset and a load. So just like we saw with our counter up and our counter down, we can reset it and or load it. So I'm going to put a value in the preset value, the PV. Let's say a value of 2, and then I'm going to load that. So once it's in there, I'm going to double click the load, and it'll put the value in there for me. Okay, so I loaded it. It's loaded with a value of 2. You'll notice the D bit, the done bit, is false, and the Q bit, Q up, is actually true once it's loaded. Okay, let me clear this. And actually, let me reset it just to show you what happens there. Reset, you'll notice when I reset it, just like we saw with the counter down, or counter up, sorry, up here, the reset will clear it to 0, right? See, it's set to 0. And the D is set to true. When it's equal to 0, when this is equal to 0, it's going to turn on the QD bit. That's the point of the QD bit. When it's at 0 or done counting, the QD bit will turn on. Okay, so forget load and reset for a second. Let's just actually count up and count down and see what happens. True. So that counted up 1. I'll count up again. 2. I'm going to do this again. I'm going to count down this time. So you should notice that, whoops. You should notice that the QD bit was on, and when I was at 2, it was on. So when it was counting up, it was, and it reached when it was equal to 2, the Q up is on. The QD or down is going to turn on once I hit 0 here. So watch this. So right off, and I'm going to do one more time there, and you see it turns the QD bit on. See that? So the QU is based on the same up bit up here. So when it reaches the value, it turns on that output. When in the QD bit is the reverse of that. It's a done bit. Once it's going down, once it goes down to 0, the QD bit will turn on. Okay. That is our timers and counters. Thanks a lot for viewing this video, and this was a little longer than my last ones, and thanks a lot for viewing it. And please do me a favor, and if you like this video, please like it and share it back on the comments, and if you're interested, don't hesitate to give me an email or poke me, and we could chat about things a little more. All right, take care. Thanks. Bye.